I re-intersected lately with my old friend John Smart, who's been around the, singularity, acceleration, advanced technology space for a long time. And he reminded me of his classic paper on the transcension hypothesis, right, which put forth the notion that when super AIs become intelligent beyond a certain level, what they're naturally going to do to maximize their intelligence is compress their processing elements more and more densely together, because special relativity says it takes a certain amount of time to transmit information. So if you want to maximize intelligence, you want to cram your processors together. So then, as John says, you get enough processors, you cram them tightly enough together. What do you get? You get a black hole, right? So one hypothesis as to, where are all the super intelligences? Why don't we hear them sending radio signals through the sky, right? In his view, the answer to that so-called Fermi paradox, it's not that there's no alien intelligences out there, and it's not that they're transmitting messages via some protocol that we don't know of. It's just that they all became smart enough to become black holes, and then maybe they're communicating black hole to black hole by some wormhole communication network, and only us civilizations that are too stupid to become black holes are still out here in the rest of the universe. Now, this is only one among many interesting hypotheses about the intersections of superintelligence in the physical world. I mean, there's also Euclides' SIPI, search for intraparticulate intelligence, notion that the superintelligences scaled themselves down, and their intelligences they're now just manifested in the high algorithmic information vibrational patterns in the quantum wave function, like the communication between elementary particles that looks random to us, right? And that would be a different route than becoming black holes, but both could have happened, right? But the black hole thing started me thinking about something adjacent, which is, suppose it was true, suppose superintelligences had projected themselves into black holes, like, is there any way we could sense them in there, even if not like send them postcards in and out? Could there be some way consistent with black hole physics where we could detect some bits of information about what's happening inside the black holes? And that led me to thinking about what Lee Smolin, the physicist, called the precedence principle, which is very similar to what my friend Rupert Sheldrake called the morphic resonance, or philosopher Charles Peirce called the tendency to take habits. Basically the notion that when a pattern has occurred frequently in the past, it's surprisingly likely to pop up again, right? More so than you'd estimate just from a probability analysis. And Smolin showed that if you assume this sort of precedence principle, that can be a key part of an axiomatic derivation of quantum mechanics. Now, there's a lot of ways to derive quantum mechanics. Charles Peirce posed this as a solution to the philosophical problem of induction, like why does extrapolating from the past to the future work, right? And Rupert Sheldrake has used this to come up with creative explanations from a bunch of things, from embryology and why chemical reactions work as well as they do sometimes, to paranormal phenomena of various sorts. I've also proposed that given the general symmetry of time at the quantum level, you should look at this going backwards as well as forwards, right? So it should be, if something is known to have occurred in the future of your present moment a bunch, then you should say, well, it's surprisingly likely to occur now also. And I've also thought about a morphic anti-resonance principle, where morphic resonance holds up to a point, but when something has occurred too much, maybe there's a saturation effect, and it's probably is actually dampened, right? And it seems to me that might explain some peculiarities in the literature on psi phenomena, where phenomena seem to work well, and then suddenly they stop working. And I've been interested in these principles both from a nature, how the world works perspective, and from an AGI algorithmics perspective, right? So in some recent work I've been doing in simulating the origin of life, what you find is that if you assume some morphic resonance and some morphic anti-resonance, I mean, you can get the emergence of lifelike phenomena in soups of chemicals to happen better in simulations. And, you know, at the chemical level, this general sort of morphic resonance or anti-resonance dynamic could pop up due to a basic principle in the universe, like Smolin and Sheldrake have posited, or it could pop up due to various more plain vanilla chemistry mechanisms. But what's interesting is the role it plays in allowing lifelike autocatalytic networks to form, right? Like morphic resonance makes it more likely for a lifelike network of interproducing molecules to come together, and morphic anti-resonance makes it less likely for the first autocatalytic set that pops up to dominate and gives room for other things to pop up, right? And I'm now, having seen how this pops up in origin of life simulations, I'm looking at how you might leverage this within algorithmic chemistry, which is a way of sort of simulating chemical dynamics to give more creativity to AI systems. And I'm looking at, in the near term, starting to implement algorithmic chemistry in the Hyperon system using our newly scalable tools for implementing Hyperon AI, like the PETA compiler for the meta language and the Mork AI knowledge graph, right? So the same role that morphic resonance and anti-resonance may play in the origin of life, as evidenced by the simulation I've been running, you could perhaps use these same phenomena inside Hyperon to help computational creativity by algorithmic chemistry work better. And that can be important, right? Because while LLMs are very smart, they're not good at grounding reasoning in the real world, which we're trying to address in Hyperon with probabilistic logic networks reasoning. But they're also not very good at being wildly creative and come up with out-of-distribution ideas. And algorithmic chemistry, where you're just having programs rewrite programs to other programs in huge catalytic networks, similar to the autocatalytic networks in chemistry, like in the primordial soup, leading to the origin of life. Like this algorithmic chemistry could be the secret sauce to radical computational creativity, which is a major ingredient in getting to human level and superhuman AGI, and it may be that imitating what happened in the prebiotic soup in the origin of life could be the key there, right? And so, with this in my head, I started thinking about this in the context of the transcension hypothesis. So, and what I concluded after some math and physics calculations is, if you have a precedence principle, so if the universe has a sort of dynamic that Smolin, Sheldrake, and others have hypothesized, where patterns that occurred in the past or will occur in the future are surprisingly likely to occur now, beyond what simple probabilistic induction would suggest. Like if you have that, then you can use that to get some dim inklings of what happens inside the black hole, and those inside the black hole could get some dim inklings of what's happening outside the black hole, right? So you could have not like radio signals from in and out of the black hole, but some sort of coarse pattern leakage, and that led me to formulate what I called the Leaky Transcension Hypothesis as a variant of John Smart's transcension hypothesis. Now, the evidence for precedence principle in physics is still preliminary. When I saw some recent results that, recent data from the Large Hadron Collider was giving some indications different than what the standard model of particle physics would suggest, I did start thinking, well, could you use either reanalysis of the current LHC results or some new Large Hadron Collider experiments? Like, could you use this to get evidence for precedence dynamics at the subatomic physics level? I think you could. However, I forced myself not to do that data analysis or think about it too much, because it seemed like it's a rabbit hole beyond what I can do in my spare time. When we have the next level of Hyperon systems and LLMs connected together, maybe I can just get them to do that research in their spare time, at least the data analytics part. I mean, running new super collider experiments is going to cost money. But anyway, the precedence principle thing is foundational physics is still speculative, and so the Leaky Transcension Hypothesis is a speculation on top of a speculation. But now in origin of life context, a little less speculative, because you could see how this kind of dynamic would pop up for various chemistry reasons, even if it's not there as a foundational physics principle. Now in an AGI context, then of course the question is just, does it work? Does it lead to interesting stuff? And whether our physical universe is clever enough to have baked it into its dynamics is a different question. We can bake it into our algorithmic chemistry systems if it's good for yielding cool results and making interesting patterns evolve more efficiently, which does seem to be the case. I thought about this. I wrote a blog post on the Leaky Transcension Hypothesis, and I posted it on my Substack, and then put a link to it on Twitter, and immediately it got me a bunch of Twitter trolls saying, why don't you focus on boosting the token price of your FET token rather than trying to understand the universe? And the thing is, of course, there's a point in being frustrated at the price of our current crypto token. It was higher not long ago, and there was a bunch of mess between Ocean Protocol, one of the members of our merged ASI alliance, which killed the token price for a while. It's now slowly coming back up. So I get people bought that token, it was higher, it's now lower. It's annoying. Like a large percent of my own net worth is in that same token. It's annoying to me. Also, on the other hand, yes, we need to move toward launching products in SingularityNet. We're doing it. We're launching a developer version of Omega Claw shortly, which is an amazing new sort of self-modifying AI agent. There'll be a full product version of Omega Claw in a few months following the developer version. We will host that through ASI Cloud and ASI Create, rolled out an ASI chain. Like all the product stuff is very, very important, and I am spending a lot of time on it, even though I don't write Substack posts about it that much. But on the other hand, what I'm trying to do with my life and what SingularityNet is trying to do is actually create an AGI and trying to get there faster than Google, Anthropic, the Chinese government, OpenAI, and so forth. And, openness, decentralization helps. We can pull in a big community there. The architecture we built so far helps a lot. Like it's the first scalable infrastructure for symbolic AI, for evolutionary AI, even for neural net training that's more heterogeneous and nonlinear dynamical, like predictive coding neural nets rather than backpropagation. On the other hand, we still need some creative ideas to make the leap from here to AGI. And I mean, where do creative ideas come from? They often come from lateral thinking and from understanding the deeper principles underlying different sorts of systems and different domains. And so, it may not be obvious, but this thinking about leaky transcension hypotheses and black holes and the origin of life, it's interesting, it's fun to think about. It's also fleshing out in my mind, in the mind of our development team, what these precedence, morphic resonance tendency to take habits, principles can do, which we can then bake into actual practical AGI algorithms like algorithmic chemistry and inference control and so forth. Right? You need creative lateral thinking to foster emergence of the last few creative insights that we need to push our already powerful systems over the edge to AGI and superintelligence.